call upon the language to produce an error for the value as large as 0.1, right? It is okay if the error happens when the value is small, right? Like 0.00001. Okay? If the machine treats that number as 0, then that's okay. But this is a big error. So that's one. Loss of precision. Number two, underflow and overflow, meaning that underflow, if the number is too small, then suddenly there's problem. Okay, if the same thing, if number is too big, then the language cannot handle that. They lose some information on that number. Okay, so for example, you have x equals to 1 to the power of 20. 1 times 10 to the power of 20, and then we do calculation x times x. So for Fortran, this is already big and might overflow, meaning that the information might lose. Okay, so again, that's another problem. For calculation in the industry in the 1970s, 1980s, they are okay with this error. They're still okay. But later on, in the year 2000, 1990s, 2000, we want to be more precise, okay, in our manufacturing process. And then number three, efficient codings of algorithms are not always obvious. For example, say that we want to do this equation: y of n equals the square root of 2 times x of n. So we want to do this 100,000 times. Okay, so in Fortran, you have to do this, the looping. You have to write the coding. I think you've learned this in Calculus, right? The for loops. This is like the for loops. So you instruct the Fortran. Okay, Fortran, we calculate y of n equals to this 100,000 times. Okay, so x at each n, okay, from 1 to 100,000 times. So this, imagine if one line takes 0.01 seconds, imagine, and then 100,000 lines times 0.01, that will be 1,000 seconds, right? 1,000 seconds is in computer time, it's very long, it's very costly, okay? It's expensive. So we call this inefficient. There are some other language that they can do this in a much shorter time, and therefore save cost. Okay, so that's number three. And number four, Fortran, they have many bugs. Okay, for those who want to be good with Fortran, they have to be good at debugging bugs. Okay, so some problems using Fortran. Therefore, so this is another example using Fortran to solve the linear system ax equals to b. Okay, so a long code. Okay, you have so many lines of code. So yes, I'm not gonna go into the details, but this is just a small example. A full program may be 1,000 of lines long. So this is another disadvantage of Fortran. It is lengthy. Okay, to just ask the machine to do one thing using Fortran, you have to type many lines, okay, to just complete one task. So, okay, this has been going on for a long time. At that time, the US government recognized these problems. Okay, we have some problems using Fortran, and the inefficiency of writing the same algorithms again and again. Okay, for example, engineers, they want to solve for a system of linear equation, ax equals to b. They have to write this again and again. the US government commissioned numerical analysts. So who are they? Who are they? They were mathematicians. Okay? Mathematicians who specialize in numerical analysis. Okay, so they hired these guys, these mathematicians, to write good quality algorithms for common tasks. Common tasks meaning like solving AX equals to B. Okay, so they have a list of frequently used computations. So these numerical analysts, they wrote the algorithms and they compile them in libraries. They make the results freely available as libraries of subroutines. Therefore, the engineers, when they want to solve some mathematics problem, they just have to go to the library and pick some codes, select some suitable codes and copy that, adjust a bit, and then compile the coding. Okay, so the libraries are available until now, still available at www.matlab.org. Okay, anyone can use these libraries in their programs. Okay, so yeah, imagine at this time, in the 1970s, I guess, 1970s, 80s, we don't have a black box model like today, right? Even in our scientific calculator, if we want to calculate for cosine, right? We just hit cosine 45 degrees and automatically we will get the answer. And at this time, they don't have that, right? They have to write the coding to calculate cosine. Okay, so these are examples of numerical libraries. So we have BLAST, LIMPAC, ISPAC. BLAST is basic linear algebra subroutines, and yeah, all the libraries. Okay, I don't want to go over this. The last time I talked to a programmer. He's a computer science professor in the United States. He told me that up until now, the mainstream language like C++, Python, Java, and also our software MATLAB, Mathematica, they still use this library, the BLAST library. Okay. So, for example, okay, when we want to solve AX equals to B, B equals to AX using LIMPAC, so we can just call the function. So this is the Fortran way of calling the function. So all the coding is stored in this function. So they just input the matrix and the number of dimension and everything and hit enter and they will get the answer. Okay, as opposed to writing this. Okay, this is sophisticated, right? They just call this function, and this function. So just 3 lines of code and we're done. Okay, that's the evolution of Fortran. And then in the 1970s, I was not even born yet. A mathematician named Cliff Moller. Okay, he's a mathematician, but he's a computer science professor. Once upon a time, mathematics and computer science, they belong together. Okay, even in the school in the United States, right? Even in USM, we used to be together, the School of Mathematical Sciences and the School of Computer Science. Okay, so because they are interchangeable, but when time passed, and then we have divided into so many areas of research, then we figured that, okay, we have to divide the schools separately. Okay, so this mathematician, Cliff Moller, he was one of the authors of LIMPAC, of one of the libraries. So was teaching, and he thought that even the act of copying the function and everything like this, even that was still too much work. Okay, because we still have to write in Fortran, we have to compile, and there are bugs, we have to debug, compile, and run again, and we have to do that again and again. So he wanted to give students easy access to LeanPack, meaning that he wanted the students to use LeanPack without the technicalities. Okay, so the term right now is user friendly. Okay, to make the program more user friendly. So he wrote MATLAB. So he was the one who wrote MATLAB at first. Okay, in the mid to late 1970s. So MATLAB became interactive, easy input and output, and operations can be performed on a whole vector or matrix at once. Okay, we don't have to use the loop, the for, the do. When we want to do matrix multiplication, we can just type a times x, then we got the multiplication, because the coding, the lines of code will run at the back of the software. So for example, when we want to solve ax equals to b in MATLAB, just one line. X equals to a. I don't remember. This is slash or backslash. Maybe slash a slash b. That's it. One line of code, and you got the answer. Okay. So when we type it, a slash b are automatically at the back of MATLAB will call this function. And what this function do? That function will call the long lines of. Okay. So yes, so this guy he's the one that makes research in mathematics and computer science easy. Starting that when we have MATLAB, and mathematicians and computer scientists want to do research, they can easily go ahead and do the research without learning the Fortran and the C++ and everything. Okay. Okay. So after he developed MATLAB, MATLAB quickly became quite popular. It was used for both teaching and research. It was also free at that time. And okay, as usual, okay, mathematician, we usually don't like money that much. We only like to do our calculations and make sure our equation is balanced and is proven and everything. So this engineer named Jack Little, so he came to a lecture by Cliff Moeller, the founder of MATLAB. So he saw the MATLAB software at Stanford University, and he saw the commercial potential, and with permission, he rewrote MATLAB in C. Okay, MATLAB was originally written in Fortran, so he rewrote MATLAB in C. I guess because C has less bugs than Fortran, and then he added some more functions. Okay, he added the M file, so we're gonna learn about on this M file. So he added many more new features and libraries, and he founded the method to market it. Okay, so now this is still here, right? The method. We installed MATLAB from the method website. Okay, so here we are. We have to pay a MATLAB now. USM has to pay yearly subscription for MATLAB subscription. Okay, but this is what happened. In 2013, I was working in Mimosarhat as a researcher there as a mathematician, and I was just doing my thing, the mathematics part and the code part. And suddenly, one computer science, the engineer over there, came to me, and he bragged to me. He told me that you people, meaning the mathematician, you people, you were doing all the hard work. We take your work and we market it and we become rich. He told me that. So he was saying that we are not smart because we are just doing the calculations and everything, and we don't get paid for that. We don't get paid as handsomely as they were. So I told him that that's our job satisfaction to develop things, to develop tools and everything. Enough money is good, but we don't really search for a lot of money. So enough money is good. So for him to be able to sell as a computer scientist, to be able to code our equations and everything, and sell and market the product, to him that's his passion. But to me, I think, and to us, I think, to mathematicians, at least most of the lecturers in our school, we're not like that. Then we are just satisfied with, proving our theory, and then, living a simple life. Okay, so this is the design context for MATLAB. So start with Fortran compiler or C++ compiler. And then we go to the linear algebra libraries. Okay, so this is at the back of MATLAB. And then we have MATLAB. So this is what we have in our machine, the MATLAB. So the background is the libraries and the Fortran compiler or C++. I'm not even sure right now they are using C++ or Fortran. And then from MATLAB, we can either, if we want to do some more coding, we can do through MFunc or through the toolkits. Okay. Yes. So MATLAB today, millions of users around the world. MATLAB is a standard tool in both professional and academic use. Toolboxes providing functions for many applications. So MATLAB has toolboxes as opposed to the libraries. So now they name that as toolboxes, providing functions for many applications. Some of them are control systems, identification, neural networks, bioinformatics, statistics, time series analysis, and many more. Okay, in fact, if we are good in MATLAB coding, if we have developed our method to solve some problem, we can write some coding and send to MathWorks. We can sell our coding as a function in their toolbox, meaning that we will get paid for what we have written. Okay, so yeah. And MATLAB, nowadays, MATLAB can perform symbolic mathematics. Okay, the one that Fortran cannot perform, MATLAB can do that. Okay, symbolic mathematics, meaning that if you want to integrate x squared, so you will get x cubic over 3 plus c in MATLAB. Okay, whereas in Fortran, you have to give the value. You have to give definite integral, integration of x cubic dx from 1 to 3. Okay, so you have to in Fortran. And also, along with MATLAB, we have Simulink. Simulink is the GUI-based simulation tool, graphic user interface, meaning that we want to, from MATLAB and Simulink, we want to produce another GUI, like the ATM machine or anything. We can use Simulink. So, what is MATLAB? MATLAB is matrix, short for Matrix Laboratory, MATLAB. So it was originally written to provide easy access to matrix software developed by Linpack and iSpec, the library projects. It is a numerical computation package optimized for matrix operations, right? Matrix Laboratory. So it's very fast. If you do matrix computations involving matrix, MATLAB is very fast compared to other softwares. So MATLAB regards a matrix as a rectangular array of numbers. Okay, I can't remember what we define in mathematics what a matrix is, but in MATLAB, it doesn't have to be numbers if you have some words. a rectangular array of words. That also is considered as a matrix in MATLAB. Well, in computer science, they don't use matrix, right? They don't use this as to-call matrix. They use array and arrays. MATLAB is also a very powerful programmable calculator. So why do we learn MATLAB? It is a powerful built-in. It has powerful built-in graphics functions to plot graphs. Okay, so that's what we do, right? Learning mathematics, we have to produce lots of graphs. So we're mathematicians, we love the calculation and everything. But in the when you're working, the people out there, they don't like, they hate the equations and everything. They love pictures. So usually in our report, we don't give the equation, the tables, and we give the graphs, right? We produce graphs for them to see. And MATLAB also has a huge library of built-in numerical functions for data analysis and etc. So we don't have to write the coding from scratch. Okay, we can just hunt for suitable functions for us to use. And then MATLAB has large number of freely available toolboxes. Well, free, this is subjective because we pay the subscription. So with the subscription, we have some free toolboxes. But if we want to use some advanced toolboxes, we have to buy another toolbox. Built-in script writing. So if we use MATLAB and suddenly we see that, okay, I want to calculate this, but there's no function, there's no toolbox for me to use, we can build from scratch, okay, the script writing and everything with interactive debugging. This is really nice. Okay, I'm not sure how you debug in C++, but in my days, I had to, when learning C++, we had to go line by line to check, we had to compile every line and then comment everything and uncomment one line and then compile and then go another line, compile until we find the bug, okay, the error. But in MATLAB, sometimes MATLAB can identify the bugs, okay? So the interactive debugging here. So MATLAB can suggest, okay, this is the part that is the error, and can even suggest the correction, okay? And then MATLAB has graphical user interface, editing content. MATLAB is easy to use. Sometimes, like if you want to do the simple calculations, like your scientific calculator, and MATLAB is widely used, there is a lot of support available. So this is also important because for any product, you will always face some problems. So if there is a lot of support, then we are fine. Okay, we can just jump into forums after forums asking about our problem. Usually, if you're doing research, right, you're doing things that nobody has done it before, and then you can discuss in the support forums available in networks. So for this slide, the source is James Brucker, A Brief History of MATLAB, if you're interested to know more. This slide is was prepared by Dr. Shakila. I edited a bit on this. And this is a picture of my husband's workspace. Okay, so I just want to suggest you, if you're not, because I was thinking of how we can learn, we can do lab work online. Because usually at labs, I would demonstrate how the programming is, and then I would walk around to see you typing, to see the students typing and everything, and if there are bugs, we would correct it right away. So now I'm thinking of if I was showing you, and you want to have more than one screen, right? To do it with me, okay? To carry out the programming with me. So if you don't know about this yet, if you have a machine, a laptop, you can buy a used second-hand monitor. One is enough, I think. Two is superb. Okay, so one, and then you can connect that monitor to your machine. Okay, take a look at the back of your laptop. You have what port do you have? Sometimes HDMI, sometimes a mini HDMI, sometimes it's VGA. So you can connect the cable from the monitor to your laptop. Then you have two screens. You can expand the screen, so you can have maybe here my lecture or my video if you're watching the recorded version, my video, and at this machine you can carry out your coding. Other way is using your cell phone, but it's a bit small. If you want to have two like this, you have to, because I think at the back of the laptop there are only one HDMI port, so the other one is USB. So you have to buy connection USB to HDMI. Okay, so that your the monitor here has to be connected to your USB port. Okay, so then you can expand maybe one screen here, you have another screen here, and you have the main screen here. If you buy the HDMI splitter, meaning that from one HDMI port and then going out to two HDMI ports, and then if you connect them to both screens, you're going to have the same image, okay, here and here. You're going to have, if it comes from one port, you're going to have the same image. Okay, I hope that you understand. Okay, well, the gamers, the guys and the gamers, they are expert in this. I think if you have a desktop, not a laptop, you have to make sure that you have some graphic cards or something in the CPU, and then you can do extension like this. Okay, for laptop, it's easy because it's built in. It's in there. Okay, so for my husband, he doesn't even like to use the keyboard, so he bought himself another keyboard and a mouse. And then yeah, so for me, I only have one screen. Okay, so that I can. So I'm sharing this screen, my second screen, and then I can drag in and out for the second screen for you to see. Okay, so if that helps. So that's a brief history of MATLAB. So now we are moving to a little bit of MATLAB today. Here, introduction to MATLAB. So usually in class, I would teach around 1 hour. So we start at 11:30, maybe until 12:30, and I'll give you time to, because it's a lab, right? To do the coding and everything on your machine. And if you have any question, you can just ask me. Okay. Okay, so let's start with lab 1. Just a minute. I hope that you open your MATLAB already. Full screen, because I'm going to bring in and out the MATLAB. Okay, I hope you can see this. So we're going to cover, there are 20, maybe we're going to cover up to 10 pages introduction to MATLAB. Okay, so I hope everybody has MATLAB on their computer. So let's double click the MATLAB. Let me share. How do I share this? Just a sec. I'm gonna close my MATLAB here. Okay, so I'm gonna go to search button because I don't have MATLAB in my desktop, so I'm gonna type MATLAB. So there it is. So just click that. So MATLAB will take some time if you're opening it for the first time. Okay. So here it is, my MATLAB. Okay. Start or open MATLAB. The MATLAB desktop consists of the following main parts. Okay, you have command window, command history, you have workspace, you have current folder, you have tabs. Let's see the MATLAB again. So you have the command window here. It is where we put our comments, okay, our instructions to MATLAB. And then we have okay. And then we have comment history here. Sometimes you don't have comment history here, so you have to go to layout, and then go to comment history, and then you choose which one you want. Okay, whether you want to see the comment history, whether you want it as a pop-up, as another window, or you want it to be a part of the MATLAB desktop. Okay, so this is my style, my preference. Okay, so this comment history, it lists out the comment that we have typed before. Okay, so before this class, I have done some testings, so it appears here for you. If you have not done anything, so this should be empty. So that's comment history, and then we have workspace down here. The workspace. The workspace will list all the variables that we have defined in here. Okay, whatever we define in the command window will be stored in the workspace. And then we have current folder here, so you can choose where you want to save your work. Okay, so automatically in my machine it saves in the MATLAB and intro in the intro automatically. But yeah, if you want to change, you can. If you want to change your work, if you want to save other place, maybe in your desktop, you can do change here. Okay, do the change here. And then we have tabs. We have home, we have plots, we have apps. So we're gonna learn about this later on throughout the semester. Okay, just so you know that when I'm talking about tabs, it's here. Tabs. T-A-B-S. Okay. Okay. Next. So I'm reading the slides, but I'm going to maintain the MATLAB here. Okay. So if you want to refer to the slide, you can download in your e-learn. Okay. So we start with command window. Command window is the most important part. Okay. This is where the action happens. This is where we give instruction to MATLAB. So we have here this symbol. So this is called command prompt. So when we have the symbol and the blinking cursor, so that means MATLAB is waiting to give any comment, any instruction to MATLAB. Okay, so the flow is we type instruction here, we type the command at the command prompt, and then we hit enter, we press enter, meaning that we execute the code. Right? And then MATLAB will MATLAB will print out the result, and then MATLAB will print out another after MATLAB is done with executing our command. MATLAB will end with this, with another command prompt, waiting for another command. Okay, so we can give instruction, we get the output, and then give another instruction. So we can interactively enter as many commands to MATLAB as we want. Okay, so for example, we click our mouse here. If sometimes if we click anywhere, sometimes we want to just be sure, we click back here. So it's blinking. So suppose that we want to know today's date. Okay, so we type and then enter. Okay, so the process is we type date, meaning that we give instruction to MATLAB. We hit enter, meaning that we say to MATLAB, okay, run this. MATLAB will run the date function, and then MATLAB will output the today's date, March 30, 2021. Okay, so if you have done this, then congratulations, you have just successfully executed your first MATLAB command. Okay, date. So this is built-in function. Okay, if we type date, we will always MATLAB will always give today's date. Okay, so here you have the command prompt again, and then blinking, meaning that MATLAB is waiting again from us for another comment. So we say that, okay, there's another function called CLC, clear command window. Okay, short form of clear command window, CLC. We enter that. Okay, what happened? The command window is cleared. Okay, sometimes we have written lines and lines and lines. There are so many things here. We feel miserable seeing those codes. We want to clear that. We want to erase that. We can just type CLC. But oh, I forgot. When you type again, okay, I'm doing it again. When you type date, enter. Okay, take a look at our history, command history. So this is this is the most the code that I've just entered. Okay, date, CLC, and date again. And take a look at the workspace. Suddenly there is a container here, something here called answer, ANS, right? So we call this variable answer. So the value inside answer is the date. Okay, why? Because when MATLAB executes the function date, MATLAB will compute the answer, and MATLAB will put that answer in the container named ans, or in a variable. So you can view this in programming like a container, right? Because this will be put somewhere in the memory of MATLAB. Okay, and then when we clear again CLC, sometimes we are lazy to type again our code. We can go back to the history. Oh, I have typed CLC, so I want to run this again. We just double click CLC. Okay, so MATLAB will automatically run CLC if we double click that. If before that we type date, right? And after that I double click CLC. MATLAB will run the instruction that I have double clicked. Okay, so the command window is again empty. Okay, so by now we have learned two functions, date and CLC. Sometimes some students, they don't they don't like to write, to type the coding, to give instruction by typing. They like to just click, or sometimes we don't have keyboard in front of us. Okay, so we can also clear the comment, the comment window in the home tab. Make sure this is home, and then clear comment. Where is it? Here, clear comment. Okay, so we want to clear the comment window. We can do that. We can also clear comment window. So this will be clean, and we can also clear the comment history. Yes, so this also will be clean. Okay? But I don't recommend clearing the comment history, okay? Because sometimes there's no harm, right, in having some logs of what our codes were. Okay? Because sometimes we want to reuse the codes. Okay, so that's CLC. And then going back here, what about demo? Okay, hit enter. And this will pop up. So this is when you type demo, so MATLAB will give you some documentation on some hot topics in MATLAB, meaning that if you want to do basic operations, Fourier transforms, you want to do some two-dimensional plots, and many more. So these are changing. These are dynamics. So MATLAB will arrange this according to the frequently searched topics in MATLAB. Okay? So yes, you can do that to learn more about MATLAB. So I'll close the documentation as demo. Later on, right? If you want to learn more about MATLAB, then you can go ahead and explore the demo. Okay. If you want to exit MATLAB, to open MATLAB, you just double click. If you want to exit MATLAB, you can just hit the cross out here, right? That will close MATLAB. But if you are a programmer and you want to code everything, you want to type every comment, you can either type exit or you can either type quit. Okay, they're the same thing. So let me type exit. So MATLAB will exit. Okay, I'm gonna have to open it again. Take some time. Here it is. Oh, this is the slide, sorry. Okay, this is my MATLAB again. See, when we quit the MATLAB, everything will be erased. Okay, our comment window will be empty. Our workspace with our end variable will also be empty, except for our comment history. Okay, so MATLAB will keep the instruction that we have given to MATLAB. Okay, anything else will be deleted. So please be careful whenever you want to close MATLAB. If you want to save some stuff, you better do that before closing MATLAB. MATLAB will not give a warning like Microsoft Word or right, like Microsoft. Like if you want to close and then Microsoft will pop up saying that do you want to save this document? So in here, MATLAB will not do that. MATLAB will do that in the script file. That's for later. So we have covered some basic functions. So now, how do we get help? Okay. So nowadays, this is the important part, right? If we want to learn about a software or anything, we want to know where should we go? Where can we go to get help if we have problems? So these are some places where you can get help from MATLAB. Okay, so if you type help in MATLAB, automatically MATLAB will give you new to MATLAB, see resources for getting started. So you can go here, okay, to the documentation and search here. Okay, get started with MATLAB and everything. If you want to help with a function, say, help me with the function date, help date, then MATLAB will give, okay, date, we have date returns text representing the current date, but it is recommended that you use date time. Okay, so you have some documentation, some short explanation for date, and then you have for more, you can click documentation for date. It will bring to the documentation of MATLAB where the documentation for date is kept. Okay. Okay, so I use this all the time. Okay, during my research. But I don't type help like this. I usually go direct here, help, and then documentation, or I just hit F1 and I search them. Okay, see here, and then suppose that we want to know 3D plotting, right? Plot 3D. So we search right away from there, and MATLAB will give some reading on plot 3D, and then we can go through one by one and see whether that answers our question. Okay, that's the function help, and then we have help win. What is that? Okay, so help win, if we type just help win, it says that we don't have input. So this is a function, we have to have some input. Okay, so help win date, it is a function in MATLAB. Okay, so it will pop up the same information as in share, but in another window. Okay, so it depends which one you prefer. Okay, so later on when you want to do some programming and suddenly you don't know, right, what this function does. Okay, so you want to type right away, you type help me with date. So it depends on you whether you like the information be displayed on the command window or in a separate window. Okay, based on your preference. And then another function for us to help from MATLAB is DOC, short for documentation. Help win is short for help window, right? It's the same as help, it's just that it appears in another window. DOC, what is this? DOC, enter. So that brings us the help center documentation. Okay, it's the same as when we click right here, F1. Is it? Let me see. Yeah, it's the same thing. So again, if you need some help from MATLAB, you can either type, do it the classic way by typing the instruction for MATLAB to open the help window, or you can go to the help button here, documentation, or hit F1, whatever you want. Okay. So MATLAB has an extensive help system built into it, containing detailed documentation and help information on all of the commands and functions of MATLAB. Okay, so we have covered help, help win, doc. So help and help win give you the same information in different windows. Doc opens a help browser with a lot more information. Alternatively, you can click the help button or hit F1. If later on, if you use all of this and you still don't get help, then you can go to www.mathworks.com for more information. Okay. Usually in my research, when I face some problems using MATLAB, usually that will be settled just by MATLAB documentation. I don't have to Google that outside. Okay. Usually they have covered everything in the document. Oh, and then now this is nice. You can automatically search right here. Okay, so example, we want to know about plot. Okay, you just type plot, and MATLAB will automatically search for plot documentations and list them out for you. Yeah, it's nice. Okay, next. So again, as practice, we want to we want to know a square root. Okay, help how to find a square root in MATLAB. Square root. Okay, when you see this, meaning that there is no function, no built-in function in MATLAB called square root like this. MATLAB has a built-in function of square root like this, sqrt, like that. Okay, so this is the limitation of help. Help and help means they can only help you with defined functions in MATLAB. So if you want to search for square root, we cannot use help, but we can use the documentation here. Let me see, square root. Okay, so MATLAB will direct you to the function sqrt. So this is the built-in function in MATLAB. We want to find the square root in MATLAB, meaning square, we cannot use square root like that. Right? You type the function square root and then 2. Enter, and we have the answer. Okay. There's another function for help, for asking help, that's look for. Look for. So for example, we want to look for square root. Oh, look for inverse. Okay, so look for will search for built-in functions in MATLAB containing that that term. Okay, we want to look for inverse. So MATLAB will list down all the functions that has the word inverse in the description. I'm not sure why look for cannot search for square root. Look for and okay, look for. So if you want to repeat your coding, you can use the upside arrow. Okay, that will bring you to the previous code. Look for square, and then you can just add it. Maybe need to write square root down for they don't know the language and they just want to search for square root. So MATLAB cannot handle space in between sentences, I guess. If we do this, oh no. If look for square root, yeah, we have that, yeah, sure. So if you know exactly the function name, then you can use all of the fancy look for, help with. But if you don't know, you can go straight to the search button of the searcher and search for square root. Okay, so here. Okay, next, what else? So we're done with getting help in MATLAB. We want to move for one concept in MATLAB called variable. Okay, so this variable is different from the variable that we learn in mathematics. Okay, this variable is under computer science. Okay, we'll see how it is different. Okay, so a variable, like my professor once taught me, just view this as a container, okay, as a place to put something in it. Okay, it's a holding place for value. It can be named. Okay, we can give some name to that variable. So, for example, let's carry out this example. So this is messy. I want to clear everything. So we do CLC. Okay. So now we want to calculate 4 plus 10. 4 plus 10. So this is one way to write it. 4 space plus space 10. But if you want to do without space, you can also. Okay. Again, according to your preference. Okay. So I like it to be apart from each other, easier to see. 4 plus 10, enter. The answer is 14. So there's a variable here. So this is a variable. There's a container named answer, ANS. The answer to 4 plus 10 is put inside the container. Okay, if you double click ANS, double click that, so MATLAB will display the value 14. This container, you can put anything inside this container. You can put a number, you can put a sentence, you can put a matrix. But if it is a matrix, then it will be written as a matrix here, right? If it's 2 by 2 matrix, then this here will be filled with numbers. Okay, close this. Okay, so let's do 5 times 10. 5 times 10. I hope you are familiar with computer language, right? The multiplication is in MATLAB is the asterisk symbol, okay? 5 times 10, enter, and take a look at our container, our answer. So that has been changed. Previously it is 14. Now this 50 has overwritten the 14, okay? So this is variable in computer science. It's just a place to put the value. So the value, if a new value is assigned to that container, the previous value will be deleted. Okay, so ANS is the default container. Okay, if we don't define the container to the MATLAB will automatically put our answer in ANS. So this is dangerous, right? If we want to keep our answers, we better name our variable. So let's do 6 plus 6 over 3. Okay, 6 plus, we want to do the addition first. 6 plus 6, so enclose that with parentheses, and then over 3. The answer is 4. Now that container 4, the 50 is changed to 4. And again, we want to do 9 to the power of 2. 9 to the power of 2. Enter. So again, that container, that value is changed to 81. Okay, so this depends on the usage later on the application. If the answer is only important at that moment, you don't want to store that answer, right? For example, this 14 is only used that one time, just that time that you need it, and you don't have to store it in a variable. Because if you want to create another variable, you would use another space in MATLAB. So that's money, right? In industry, that's money. So we want to save costs as much as possible. So for the answer that we just need a one-time use, we just let MATLAB store that in ans temporarily. So the variable ans is short for answer. The variable ans. It is used as the default variable name when none is specified. It can be called or referred by typing ans. If a new equation is entered, its value would change. Okay, so we can call a variable. Now we want to know. Suppose that we don't have access to looking at Workspace. We want to know the value of ans. We just type ans, enter, the MATLAB, meaning that this the computer science term is fetching. We are fetching the value, F-E-T-C-H. So MATLAB, tell me what ans is. So MATLAB will tell us ans equals to 81. Okay, so next. So how do we name a variable? We don't want ans, we want to give a name to that container. So we have to give name. Suppose that we want to give the name A. The container, we want to call it A. So A equals to. So we use the equal sign to assign some values to that container. Okay? Assign one value. Okay? So A equals to 10. Enter. So this is our instruction. MATLAB will display. Okay, I got it. A equals to 1. Take a look at the workspace. There's another variable called A, and the value is 10. Okay? B equals to 20. And again, another container named B, the value is 20. C equals to 30. Okay? So now we want to call that variable back. We want to fetch the value of A. We just say A. Hit enter. Now A equals to 10. Okay? So this is useful when you do coding. You have the workspace here. If like this, we can automatically see, okay, A equals to 10, then that's fine. But sometimes when you do research, this is full. This has hundreds of variables in this. So sometimes we want to, it's faster to just call from here. Okay, I want to know what the value of A is, because A would be somewhere in the list, not in the long list. So yes, this fetching is sometimes useful at that time. You can use letter as your variable name. You can also use some meaningful name, right? For example, if you want to calculate the average of A, B, and C, right? So you can name it as B average. Okay? So MATLAB cannot have space in between. The name of variable cannot have space in between. So the underscore, so usually we do B underscore average, or another, I prefer this more. Like that. Okay? So you make that capital. The second word. Okay, just a second. Sorry about that. Okay, so this is the second style of writing the name of variable. D, and then the starting of the second word is you capitalize the the letter. Okay, so the average, what's the formula of average of three numbers? You want to add those three numbers, right? A plus B plus C. Close the parentheses because you want to do that first, right? You want to do the summation first, and then you want to divide by 3. Enter. So that's the average equals to 20. So in your workspace, you have that. The variable name, the average, and the value is okay. I hope everybody's good until here. And then there's another built-in this. All the variables, whose will tell us the size of that variable, the number of bytes used to store that variable, the class, the class of the variable. Okay, we're gonna learn about this more, and then the attributes of the variable if there are attributes. Okay, so that's useful when later on, if you have so many lines, so many variables defined in your workspace, and then you want to name another variable, right? For example, you have so many things right here, and then you want to create one container, you want to name one container, and then you want to say name it as V, but you don't remember whether you have that variable name in your list or not, and this list is long, then you can call host to see your list of variables in the command window. Okay, and another useful function that is called clear. Okay, we have learned CLC, right? CLC empties out the command window, and now we have the clear function. What does that do? To enter, take a look at our workspace. Suddenly, all our well-defined variables are erased. So that's what clear do, meaning that if you're done with your calculations and everything, and you want to start a new calculation, you can just hit clear. Usually in MATLAB, we do that simultaneously. We clear, comma, CLC. Okay, we want to clear the workspace. We want to also clear the command window. Do this, and everything is clean. Okay, so we can start, maybe we have solved one problem, we want to start solving another problem. So we clear everything except for the comment history. To clear the comment history, you have to go to the clear comments and then clear comment history. But again, I don't really recommend you to clear the comment history because that's there for a reason. Okay, more important notation in MATLAB. So suppose that I want this. So I'm selecting from my history. Okay, A, B, C. I'm hitting my control button here, control, and clicking the code that I want. A, B, C, and the average, and then enter. So all the codes that we have highlighted will be compiled again. Okay? This is nice, right? You don't have to write over and over again. Okay? So suppose that, take a look at this example. You're defining A, B, C, the average. From the perspective of the question only only asks the average, right? The value of the average. So we don't really want to see this A, B, C values here, right? So the other way of writing this code without displaying A, B, and C is by adding a semicolon at the end of the lines. Okay? I'm using my upward arrow key. Okay? Let's say A equals to 10. I want to define this value, but I don't want to see the output in the command window, so I add the semicolon. A equals to 10. Enter. So MATLAB will compile that, and then let window A equals to 10, semicolon, enter. So here we have a container named A, the value is 10, but the output is not displayed here. Okay? B equals to 20, semicolon. B equals to 30, semicolon. Okay, so all the values are stored but not displayed. B average, so you can just type B and then hit the upward arrow. So that will go to the most recent code starting with B. So that's useful, the average. So this part we want to see the output, the average. Okay, so we don't put the semicolon here. Hit enter. The average is 20. Okay, so that's the use of semicolon. Remember, in our coding later, we will have many lines of codes, right? We don't want to see all of them, all of the outputs. So we just select the one that we want to see, and we put semicolons at the end of everything that we don't want to see. Okay? So let's try that. So again, I'm showing the notes for semicolons under suppressing results. Semicolons typed after comments can be used to hide the printing out of results. This is a way to hide the output from displaying on the screen. If you type an expression and then follow it with a semicolon, then MATLAB will evaluate the expression and store the result internally, but it will not print out the results in the MATLAB comment window for you to see. Okay, so that's semicolon. And then we move to the rules for naming variables. Okay, so now for any calculation, it is going to be useful for us to name the variable like this, right? A equals to what, B equals to what, C equals to what. Then our equation will become easier to type and easier to change. So for example, if you want to find the average for another 3 values, we can just change it, right? And then we will automatically get the average. So the naming of the variable is pretty useful, but there are some rules for naming the variable. Let's see. So if you want to name your variable, you can use all the letters, all the primary alphabetic characters, A, B, C until Z. Okay, don't use the Greek letters, alpha, beta. Okay, it's not allowed. It's just if you want to use alpha, you have to spell the alpha, right? Alpha equals to 30, like that. Okay, that you can do. And then you can numbers on its own, meaning that you can use alpha 1. Alpha 1 equals to 20. Alpha 2 equals to 40, like that. You can do that. But you cannot name a container by a number on its own. Let's say you want to do 1 equals to 2. Right? You want to create a container. That container, the name of the container is 1, but the value inside the container is 2. Do that, enter. Okay, so you cannot do that. Okay, you cannot name a container as a number by itself. Okay. And you can use the underscore character. Okay, so you can do alpha 1 like that, or you can do alpha underscore 1 like that. Whatever you like. Okay. And then MATLAB does not allow spaces in between the names, only numbers. And then MATLAB is case sensitive, meaning that if you do alpha is 1, so that's the purple color, meaning that some error equals to 10. Okay, so you have error. Okay, and then if you do case sensitive, so alpha, let's do beta 1 equals to 10. So, and then we have beta with capital letter B, beta 1 equals to 20. Our difference. So if we search for here in our workspace, we have beta 1 with 10 in it, and we have the capital B, beta 1 equals to 20. Okay? So please be careful. Usually, from experience teaching past classes, usually error will from the naming of the variable. Some of you, at first, you name the variable with small letter, and then towards the end, you call the with capital letter. Sometimes you have both. Sometimes the previous students, they have both definitions. Beta 1 with small letter and beta 1 with capital letter, but they call the wrong variable. Okay, they should be calling this variable, but they call this one instead. Okay, things like that. So make sure you'll be smart at naming your variables. Give some meaningful names to your variable. If you give A, for example, A equals to 10, then you do not know, right? You do not know what A is. But if you can give some meaningful name, for example, length equals to 10, then automatically you know that, oh, and it's easy to code. It's easy to call later on when you want to call the length. You can just type the name. Okay, length equals to 10. If you use A equals to 10, then later on when you want to call, for example, you use length as A, and then later on when you want to call the length, you don't even remember that length is stored as A. So yeah, give a meaningful name to your variable. Okay, that's it. I think I'm gonna cover strings for next week. Okay, we have some more slides, like 3 and 4, maybe 7 slides for next week. So we are done until the rules for naming variables. Any question? So I have made available the quiz, the lab work for this week, this attendance lab work 1. So you want to hit that quiz And I cannot attend this. I can preview the quiz. This is the question. Okay. So what I want you to do is write just the coding. Okay. Define a variable, name angle to be 45 and everything, and then repeat for these values. So what I want you to do is just write the coding for to answer these questions, and don't give me the answer. Give me the coding. Okay. For example, if I go back to my MATLAB and I've written. Okay, I clear it. I clear this. Clear. Yeah. So for example, my coding is this: ABC, the average, right? So this is giving me the correct answer. So what I do is I copy the relevant coding. Okay, 1, 2, 3, 4, and then copy, and then go to here, paste. Okay, and finish. Submit the answer. Because what I would do is I would just copy your submitted coding and I would paste in my comment window, and then hit enter and see whether that coding is giving me the right output or not. Okay? Any questions? Okay. If there's no question, then I'll see you next week, inshallah. Thank you.